This video is about axial symmetry. This means symmetry in an axis. So axial symmetry just means reflection in a line. On this page I have two axes. My x-axis, the horizontal axis, and my y-axis, the vertical axis. Here I have a triangle on my xy plane. This is the shape that I'm starting with, so it's called my object. I'm going to use axial symmetry in the x-axis on this object. This means I'm going to reflect it in the x-axis. When I do that, I get this result. This new triangle, which is the result of symmetry, is called my image. Returning to my object once more, I can also reflect it in the other axis, the y-axis. Take a moment to imagine where you think this image would be located. In this case, my image is on the left of the y-axis. Notice that the distance from every vertex on the original object to the y-axis is the same as the distance from the y-axis to the image vertex. So this point has a distance of 3, and now I've got a distance of 3 to get to the image. This point was a distance of 3 units, and it's 3 units to the image point. This point was a distance of 7 units, and it's 7 units on the far side out to the image point. This rule was also true for our image under reflection in the x-axis. So looking at the individual vertices in the object, to get to the axis is a distance of 1, and then a distance of 1 on the far side. From this vertex, a distance of 1, a distance of 1 on the far side. From this vertex, a distance of 5, and then a distance of 5 on the far side. Symmetry in the x-axis can be abbreviated as a capital S for symmetry and a little x to represent the axis x in which the object was reflected. Symmetry in the y-axis can be abbreviated as SY, S for symmetry, and Y to represent the y-axis. Next, I'm going to take you through how to construct an image on a coordinate plane. So here I have my object. The first thing that I should do is identify the vertices of the object. Well, this is a quadrilateral, so it has 4 vertices. So to find the image, I'm going to have to move these 4 vertices, find their images, and then join them up to make the image shape. This is quite straightforward to do on a coordinate graph because I have the grid lines to follow. I'll take each of my vertices in turn, and I'll draw a line straight down to the axis. And then I'll continue that line out the same distance on the far side of the axis. So in this case, my image point is here. I'll repeat this for the next vertex. This vertex is a distance of 2 from the x-axis. I can draw my line to the x-axis, 2 spaces, and 2 spaces out the far side. Here's my image vertex. I move to my next point. Same thing again. I see this time it's 5 spaces from the x-axis. So I draw my line to the x-axis and then 5 out on the far side also. And again, I mark my image vertex. Finally, last vertex was a distance of 2 from the axis. So I'll draw my line and out the far side. And my final image vertex is located here. To finish off my image, I'm just going to join each of the image vertices together to make my quadrilateral. And finally, my image quadrilateral looks like this. This is the image under SX. We'll often see the word under being used in this context. In this context for symmetry and transformations, it just means using. So when we say the symmetry under SX, we mean symmetry using SX. Copy this diagram yourself for the original object and construct its image under axial symmetry in the y-axis. Pause the video and then play to see if you're correct. In this case, the image under SY is this quadrilateral here on the left. One last point to note, any of the construction lines that I drew in yellow, you'll notice that if you compare them to the axis they're going through, they're always at right angles to the axis. Whether I'm doing symmetry in the x-axis or symmetry in the y-axis. And that's why it's so straightforward to do constructions for symmetry on the coordinate plane, because the grid will always be at right angles to the axes. So now we're going to look at axial symmetry in any line, not just on the coordinate plane. And we're going to do construction. And for this construction, you'll need a ruler and you'll need a set square. And either of those will do. Doesn't matter which one you're looking at. So here I have my object and it's a triangle. And here I have my axis, which is just my straight line. And I'm going to call this line the line K. I'm going to call the vertices of my object ABC, so I can refer to it as the triangle ABC. And my instruction is going to be construct the image of the triangle ABC under symmetry in K. So just like before, I want to take each vertex, I want to bring it to the axis, and I want to bring it out the far side. And like I mentioned with the coordinate plane, it's really important that any of those lines that you draw when finding your image vertex have to be at right angles to the axis or the line that you're given. So that's where our set square comes in, because if I rest the set square on my axis, then straight away any line that I draw in this direction is going to be perpendicular to it. So I'm going to place my set square on my line. Notice I have it lined up perfectly. It's really important to be as accurate as you can with this. Now what I don't want to happen is I don't want to run into two pitfalls. First one is that I end up getting caught out by this little divot at the end of the set square, which will end up creating kind of a dent in my line. I don't want that. And I also need to be able to measure out to the far side, but if I move my set square off the line, then I no longer have a perpendicular line. So to get over that problem, what I'm going to do is I'm going to line my ruler up with my set square. Okay, now how do I get at the point? Well, what I'm going to do is I'm going to push my set square and my ruler along until I can get at that point. Then I'm going to carefully, I'm actually going to turn around my ruler, sorry, at the moment, because that actually didn't suit me. I was on the inches side by accident, checking that everything is still lined up perfectly. I can see that the distance from my axis to my point is 3 centimeters. So I'm just lining up my very first dash there with my line. It's 3 centimeters out. So I need to push my ruler so that I am 3 centimeters out on the far side. Now everything's after moving slightly for me here. So again, I have to take care that everything is lined up perfectly. So I have my set square lined up with my line. I have my ruler lined up with my point, and I can see I've got 3 centimeters, 3 centimeters. I'm going to draw that line in now. So when I've drawn that line in, the very end of that line is the image of A. And you may recall from our last video on translations that we can call the image of A dash. Now I'm going to repeat this process exactly for B and C. So I'm going to push along here. You can see I'm going to, at risk of falling off the end of my line. It's a bit of a nuisance. If I need to, I can extend my line to avoid that problem. So I'm going to do just that now. So I've extended my line. I don't want my set square to be just balancing on the very end of that line. I want it to have plenty of space. So next I'm going to look at the point C. Okay, so lining up perfectly. Okay, I'm not quite lined up with my point. I want to bring it down here slightly. Okay, now I'm lined up a bit better. And if I put the very first dash of my ruler on my line, I can see the distance as far as C is 1 centimeter. So I'm going to push my ruler out so that it is 1 centimeter on the far side of the line. So you can see now that I've got a distance of 1 centimetre to the line and then 1 centimetre out the far side. So I'll draw my line now, and then my vertex, that is the image of C, is at the end of that line. C dash. I still need to get at B. So if I push out here, I can see that lining up carefully and setting up my ruler so that my very first dash of the ruler is on the line. The distance from my line to B is about 3.4. So I'm going to say, okay, what's double 3.4? 6.8. So I'm going to slide my ruler along until B is on 6.8. And I can see that I've got a distance of 3.4 over here. So I'm going to draw my line now. And then the vertex at the end of that line is the image of B, which I can call B dash. To finish, I'm going to join up the vertices A dash, B dash, C dash. And this new triangle is the image of my original triangle ABC under symmetry in the line K. We may also be asked to decide whether a shape has an axis of symmetry. Don't forget, an axis just means a line. To determine if a shape has an axis of symmetry, imagine that there is a line down through the shape. Is each side of the line identical? Would I be able to fold the shape over exactly on itself? In this case, this square has an axis of symmetry vertically. It also has an axis of symmetry horizontally. Can you see any other axis of symmetry? This particular shape, the square, has an axis of symmetry along each diagonal also. What about this shape? How many axes of symmetry do you think it has? Well, it definitely has an axis of symmetry here. And it also has an axis of symmetry here. Does it have a diagonal axis of symmetry? It's a little bit hard to tell on first glance. One way to check is to actually take the shape and try to fold it along the line you suspect may be an axis of symmetry. If it is in fact an axis of symmetry, the shape should fold up exactly. But I can see here that when I fold along the diagonal, the two halves that it splits the rectangle into don't overlap perfectly. So the diagonal is not an axis of symmetry for this rectangle. This rectangle only has two axes of symmetry. Not every triangle has an axis of symmetry. Scalene triangles have no axis of symmetry. Isosceles triangles like this one have one axis of symmetry, whereas equilateral triangles like this one have how many axes, do you think? Well, they've got one, they've got two, they've got three axes of symmetry. Here's a couple of tasks for you to do. Draw a parallelogram and use squared paper to make it easier for yourself, and decide how many axes of symmetry it has. You can draw those in and then check if you're right by cutting it out and folding it along those axes and see if it'll fold over on itself. The second task is follow the same instructions for a rhombus. What's a rhombus? If you're not sure, look it up first of all and be careful with its construction.